Hello guys, this is Carter from QED, and today I'm going to be showing you how to check signatures in a tapscript using opchecksig and BitIDE. To get started, you'll first need to pull the latest version of BitIDE. So to do that, we just run docker pull. And once that's done, we can start up BitIDE by running docker run. And now that Docker is started, we can head over to localhost 1337, create a new project. I don't know, we can call it checksig. And click over to the project, and we have a fresh project to start with. Now, let's get into checking some signatures. So the first thing we're going to want to do is create some keys so that we can sign stuff. So we'll head over to Wallet Manager and create two new reg test wallets. The first one we'll call user1, and the second we'll call user2. And these are going to correspond to two different keys that are allowed to spend a script, given that they complete some challenge or provide some preimage to a hash. Now let's create the locking scripts, one for each user and one for each public key that we're going to check. So we can do, I don't know, user1 lock.basm and user2 lock.basm. Great. So the way that the opchecksig instruction works is we're going to do opchecksig, and we're going to need to provide it some signature and public key, right? So the signature is going to be generated when we actually make the transaction. So we'll put a dummy value in there, but we'll get to that in a second. But this is just like the basic sort of syntax or argument format for opchecksig. Now the public key we know, so we can head over to the wallet and let's do maybe user2 first. And we can just copy over the public key. So the public key for user2 is going to be this. However, we want to delete the first byte because we only need the x coordinate. So here we have the public key. And for the signature, well, we don't know what that's going to be until we actually do the transaction. But have no fear, BitIDE has a nice feature for testing scripts. So as long as we're inside the end example witness and we want to, I don't know, check out or test some checksig, we can actually create a dummy signature, which is just question mark followed by the public key hex value. So it's a total of 65 characters, which is the same length as Schnorr signature, so it'll work nice with your scripts. And now if we actually go to run the script, it's in fact going to return 1, but if we change this at all, it's going to return 0. So this signature, quote unquote, is only going to work for this public key. We also have other dummy signatures that work for all public keys, but again, this will only be relevant when you're testing and developing locally. But okay, cool. So we've got the basic checksig working. Now let's, I don't know, spice it up a little bit more. We can add some preimage that I have to provide, or some hash that I have to provide the preimage for, rather. I don't know, we've put in some super secret value, and we're gonna, I don't know, use op hash 160 and return op return, just so we can see what that actual hash is. So the hash of super secret value is this. So to add that to our challenge, we can just put in op equal verify. So it's going to hash this value and make sure it equals this, and then check the signature. And if the signature is valid and the equal verify passes, then the only thing left on the stack is going to be a 1, which means we can spend the tapscript. Great. So now all we have to do is do the same thing for user1, and we'll be good to go. So I can just copy this over to user1. We're just going to need to, of course, change the value there as well as the public key. So let's substitute in user1's public key over here. So again, clearing the top byte. Oh, whoops, this is user2. Haha. Public key for user1 is this one. So again, clearing the top byte, and we're just going to paste that in there so that we have a dummy signature for him. And now we can make some other secret, I don't know, some other secret value. And we're just going to op return again just so we can pull that off the stack. Great. Change that to that. And we are good to go. Okay, so now we can put away the wallet. Just go ahead and close that there, and we have our two scripts looking good. Now we'll head over to the tapscript runner, and select our locking scripts, compile the UTXO, fund it via RPC, wait a few seconds, and now we can select a lock script. So you can see a new feature here in BitIDE for the qedprotocol is that now we can choose a signing wallet to actually add a signature to your script. So if I click use example witness, it's going to pull in the fake signature, but we don't want that. That's not going to work on mainnet, right? So we're going to delete that and then select a signing wallet. Now if I select user2 for the user1 lock script and I try to unlock the UTXO, it's going to fail because it's not the right key. In addition, if I select user1 but I put in the wrong preimage, like I don't know, like that, it's going to fail. But if I do put in the right preimage and I unlock, it works. So I go over here, we can see the transaction, and we can do the same thing for the second user. Again, compile, fund, and go to the second user, user 2, example witness, delete, unlock. It works. Ta-da. And that's how to use opchecksig and BitIDE to verify signatures in a tapscript. Looking forward to the next tutorial. Take care and have a great day.